All right, thank you so much for joining us. And don't forget to subscribe and share. And this, we are going to look at four 2023 final exams to prepare us for the final exam. So this is going to cut across exam 1, exam 2, and exam 3, and then the last part that we did after exam 3. So stay here and let's learn together. Okay. So the first one is asking us to find the derivative of the following functions. Do not simplify. Okay. So now what are we going to do with this function here? So we can see that we have two functions here. So this is good for us to use the product rule, right? So I'm going to assign this one to be my A, this one to be A and B. So I can choose X to be A, and I can choose my B to be equal to the cosine of 3x. So I need A prime, which is going to give us 1, and then I need B prime, which is going to give us, so when I differentiate cos, I'm going to have minus sine of 3x. Now this is change rule, so I need to multiply this one by times the derivative of what is inside the parenthesis here. So when I simplify this, I'm going to have minus 3 sine of x, 3x. So we know that product rule says that if I have two values, or a and b, then I'm going to have my f prime of x to be equal to, I'm going to have a prime b plus a b prime. So this is going to give us, just multiply this to this is going to give us cosine of 3x minus, when I multiply this to this, I'm writing minus because this is minus, right? So that's basically what I'm doing here. So this is going to give us 3x sine of 3x. So this is what we are going to get at the end of the day. Now, if you know how to do this, you can just go straight, differentiate this, maintain this, then maintain this and differentiate this. So if you know how to do it straight, you can just go straight and just do it. But it's always advisable for you to pick your A and B. If you are using U and V, you can also do that to make sure that you avoid some mistakes. Now let's look at B. Now B is the natural log function. So what we are going to do is, we know that the natural log of U, if I'm taking the derivative, so it's just 1 divided by U times U prime. So when you compare this here to this, we can see that our U here is 9 minus x to the power 3. So I need U prime, and this is going to give us minus 3x squared. So what is f prime here? Now f prime of x here is going to give us 1 divided by U, right? But my U is this. So I'm going to have 9 minus this times U prime, which is here. So this is going to give us minus 3x squared. So this is what we are going to get. Do not simplify, but let's simplify this and have this divided by 9 minus x to the power 3. Okay, so these are very short and simple. Now here we need to use the quotient rule. So I'm going to say that this is equal to u divided by v. So I'll have my u to be equal to 5x plus 1 and my v to be equal to secant of x. U prime is going to give us 5 and v prime is going to give us secant tangent. So don't forget, when you differentiate secant, we get secant tangent. Now what's the formula for finding what's the formula for using the quotient rule? So now f prime of x is equal to, we can either have v u prime minus u v prime divided by v squared, or some people like writing u prime first before v minus v prime u divided by v squared. All of them are the same because this is like product, so anytime you have product, it's commutative. So I can interchange u and v here, u and v here. So it's correct here. So now let's just try and do substitution here. But I just want to use the first one. So I'm going to erase this one. So now this is going to give us, this is going to give us v is secant x, u is 5x plus 1 minus, so we need u prime rather. So u prime is 5x minus u is 5x plus 1, and then v prime is secant x tangent x divided by secant x squared. So the question is saying that do not simplify. So I can decide to leave my final answer here and I'm done, right? So I'm not going to simplify this. I'll just leave it here. Now let's look at D, then we'll look at the next question. So D is very nice. Now we have f of x. So since the question is saying that we should find the derivative, so it means that we need f prime of x from this, right? And that's why I'm going to give you a shortcut, or let me say a formula that's going to really help you do this. So let's assume that I have a function f of x which is equal to a of x, b of x, and then f of t dt. Now if I want to differentiate this function, this is what I'm going to have. It's going to be f prime of x to be equal to d over dx. Then I'm going to integrate from a to b, f of t dt, right? And that's basically what we just want to do here. We want to find f prime. Now what is this equal to? Now this is equal to, it's very simple, this is equal to now b prime. So I pick the b here, I take the derivative, then I write the function, but I'm going to plug in the b for the t. So this is going to be b prime f of b minus, then I go to the lower limit which is a prime, then I plug a inside the function. So this is what we need to use anytime we find a function like this. So it's very simple. How I tell my students is like, you can try to think about it like this way: plug in b inside the function minus plug in a inside the function. And when you are done, don't forget to differentiate what is inside to multiply, right? So that's basically what is happening here. So b prime, a prime. So now let's apply this one here. Now what will be f prime here? F prime of x, if I'm just doing it simple, I'll be like, okay, now let's plug in x inside the function. So when I do that, I'm going to have tangent of x plus 1 minus plug in 3 inside the function, and I'm going to have tangent of 3 plus 1, right? But don't forget to differentiate what is here, and differentiate what is here. So now when I differentiate x, I'm going to have 1. And then when I differentiate 3, I'm going to have 0 because 3 is constant. So this is going to be giving me 0. So I'm going to have something like 0 times what is there. And 0 times this will just go to 0. So this is going to be left with tangent of x plus 1. So it's very simple. It's just, if you want to start now, for now you can decide to learn this and be using what is my a, what is my b. But it's very simple. Plug in the upper limit inside the function, plug in the lower limit inside the function. When you are done, don't forget to differentiate what is here to multiply the first one, and differentiate what is here to multiply the last one. It's very simple. So this will be f prime. Good. Now let's move to the next question, which is question 2. Now question 2, we have two robots leaving the same duck at the same time. So let's assume that we have something here. Let me assume that this is my duck here. Now one is moving, one is going east and one is going to the south. So let's assume that this is going to the south, right? And this is also going to the east. Let's have something like this. So when I have something like this, Now I can now say that, okay, this is my y and this is my x. So definitely we are going to form Pythagoras theory. So I just need something like joining them together, right? So now let's continue reading and find out the rest of the function. So 90 minutes later, the one traveling south is 3 miles from the dark. So 3 miles means that the one from the south, this is the south side, right? So let me put S here, and this is the east side. So the south side is now 3 miles. So y is equal to 3. Now it's moving at 2 miles per an hour. So this is going to be dy over dt, because we are looking at the change, right? We are looking at the change here, miles per an hour. So this is going to be the change, and this is equal to 2. And then at the same time, the one traveling east, which is here, is 4 miles from, so this is now equal to 4, and also moving at 1 mile per hour. So this is going to be the x over the t, which is equal to 1. So this is the information that we have. So now the question is asking us to, at this time, how fast is the distance between them? Okay, so definitely we are looking at what is here, which was right. So now let's assume that the distance between them is equal to z. So it means that here we need to use the Pythagoras theorem. So let's do that. We are going to have x squared plus y squared is equal to z squared. That's the Pythagoras theorem. So now we can find for z, right? Because we know y and we know x. So let's do that quick before we even find our function. So when I do the substitution, I'm going to have 4 squared plus 3 squared is equal to z squared. So this is going to be 16 plus 9, which is equal to z squared. This is 25 is equal to z squared. And when I take the square root on both sides, I'm going to have z to be equal to 5. So we have z is equal to 5. So now we want to know the change, right? The distance. So what we are going to do is we need dz over dt. That's what we are looking for. So because of we need this, we need to differentiate this with respect to time. So let's do that. Differentiate 2x, and we are going to have 2x dx over dt plus 2y dy over dt, which is equal to 2z dz over dt. So this is what you are going to get from here. Nice. Now what we are going to do again here is, now we just need to do direct substitution. So I have x, I have the x over the t, I have y, I have dy over the t, and then I have z. So the rest is just substitution. So let's do that. This is going to be 2 times 4 times 1 plus 2 times 3 times 2, which is equal to 2 times 5 dz over dt. So let's do that. This is going to give us 8 plus 6, 12, which is equal to 10 dz over dt. So this is going to give us 20 is equal to 10 dz over dt. Now we divide through by 10, and we are going to have dz over dt to be equal to 2. So this will be the time changing between the functions. So we are going to have it to be 2. Nice. Now let's look at question 3. Now question 3, we have, we consider a net area enclosed by this on the interval -2 and 1. Estimate using R4. So R4 means that we are going to right hand Riemann sum. Okay, it's already written here, and we want to divide it into what? 4 subs, right? And we sketch these functions too. So as I said, if you are moving from the right, then it means that we are going to start from the end of the domain, and then we head towards the initials, right? So since this is right, it means that we are not going to use the initial, the first domain here, right? So after we have gotten the subs, we are not going to use this one, the first one here. If we are moving on the left too, we are not going to use the end domain here. So that's basically the difference between the left and then the right. So now let's see how we can do. So first we need the change, right? So del of x is equal to b minus a divided by n. Now from the question, domain is minus 2 and 2, meaning that this is our a, this is our b. And this question is saying that we should divide it into 4 sub-interval. So our n will be equal to 4. So meaning that we are going to have 2 minus minus 2 divided by 4. And this is 2 plus 2 over 4. And this is 4 over 4, which is equal to 1. So it means that we are going to divide this one into, like, the time step. We need to move 1 unit, right? So now let's start with the first domain. So the first domain is x naught. Let me call it x naught, which is minus 2. So I need to increase this till I get to 2, right? Because the domain is minus 2 to 2. So we should be staying between 0 and 2. So it means that what will be x1? x1 is, the change should be, the step side is 2. So I need to add 1 to this, the previous one, which is going to give us minus 1. x2 will be add 1 to this, and this is going to give us 0. x3 will be add 1 to 0, we are going to get 1. x4 will be equal to add 1 to this, is going to give us 2. So since we have gotten to the end of the domain, which is 2, we stop. So now we are starting from minus 2 up to 2. Now this is right. So let me write it this way so that you can see it well. So I have this here. Let me move this one to here. Let me move this one to here. And let me move this one to here. So since it is right, we are not going to include this because we are starting from the end domain to the last one here. So this is right, meaning that we are going to move from this up to here, right? This is right. Now, if we are going for the left, we will start from this up to this. So from the left, we don't add the last end domain, right? The last end point here. And if we are going to the right, we don't add the initials here. So it's very simple here to have it in mind. So now the question is saying that we should find for the right. So let's do that. When we finish, we will find for we will sketch it. So let's do this. Now, since we have the base, which is the change, we need the height, right? So that we can multiply. So now let's look for them. We don't need this, so we don't need to even solve for this. So we need f of x1, which is equal to f of minus 1. We need f of x2, which is equal to f of 0. We need f of x3, which is equal to f1. We need f of x4, which is equal to f of 2. So let's use the function given to us. So the function given to us is y, which is the same as f of x, which is equal to 3x squared. So now let's try and solve them. So plug in minus 1. This is going to be 3 minus minus 1 squared. And this is going to give us, let me put my area. This is going to be 3 minus 1, which is equal to 2. Then plug in 0. 3 minus 0 squared. This is 3 minus 0, which is equal to 3. Plug in 1. 1 squared, which is going to give us 3 minus 1, which is equal to 2. And plug in 2. 3 minus 2 squared. This is 3 minus 4, which is equal to minus 1. Good. So now what is the right? Now R4, because we are dividing into 4 sub-intervals, is going to be just the change in x, and then we are going to have f of x4 plus f of x3 plus f of x2 plus f of x1. I like writing it from the highest to the lowest because now when we are thinking about the right, we are thinking about starting from the last endpoint and moving towards the initial ending point, but you're not going to include this. And then if I'm writing for the left, you will see that I'll start from x0, x1, x2, and then x3. Then I'll pause. So that's basically what I do. So we know this change, which is equal to 1, and then we know the whole of this. So we can just substitute them. So the change is just 1. F of 4 is minus 1 plus f of 3 is 2 plus 3 plus 2. So this is going to be kind of very simple here. This is going to be, this and this will be 1. So we need to get 6 from this. This is going to give us 6. Good. Now we are done. The question is asking us to sketch. So let's try and sketch something. Okay, so let me show you how to do the sketching. When I finish, so the question, okay, let me do the bonus one, right? The question did not ask us, but let's try and find the left. Let's assume that the question is also asking for the left. Then it's going to be the same thing, change. So as I was saying, this one, because the left, we need to start from the first initials here, then I'm going to start from x naught. So this is going to be f of x naught, f of x1, f of x2, plus f of x3. So I'm not going to include f of 4, the last domain, right? So here, if we are finding the left, then I need f of minus 2, what is like f of x naught is equal to f of minus 2. And when you plug in minus 2, you are going to get minus 1. You get it, right? So we are going to get minus 1 there. So this is going to be the same thing. It's also going to give us 6 because it's the same thing there. So this is going to be 1. This is minus 1 plus minus 1 plus 2 plus 3 plus 2. And this is also going to give us 6. Unfortunately, we are getting the same thing right from the left. So now let's try and sketch the graph. I have this and then I have that. So one way to sketch the graph is we can use what we had here to sketch. You get, right? So let's assume that I have minus 1 here. So let me bring this one down small. So let's assume that I have my minus 1 here. I have 0 here. I have 1, 2, 3, and I have 4 here. Now let's try and sketch this. Let me increase it small because my Hz value here is 3. So let me put 1 here, 2 here, and 3 here. So 1, 2, 3. Now x values are minus 1 to 2. So x values, I have minus 1, 0, 1, 2. So let's try and plot this. So we are using everything that we have. So x naught, which is minus 1, x naught, which is minus 2, is minus 1. So minus 1 will be somewhere here. So, oh, did we have minus 2? Yes, we had minus 2. So we need to put minus 2 on it. So minus 2 will be here. So minus 2 is minus 1. We are going to have it somewhere here. Then minus 1 is 2. So we are going to have it somewhere here. 0 is 3. So we are going to have it somewhere here. 1 is 2. 1 is 2. And 2 is minus 1 again. So the graph is going to be like this. Oops. Great. So this is how the graph is going to look like, right? So now what we're gonna do here is we are trying to sketch, but this one is asking us to sketch from the right because we are using the right. So from the right, the most important thing here is from the right, we need to start from the right. So we start from the last point here, which is 2. What is f of 2? F of 2 was minus 1. So it means that the height is minus 1, right? So when I stand at 2, let me use black so that you see it. When I stand at 2, I need to move a height of minus 1. So minus 1. So this is the height for this one. And what I'm going to do is, now I will extend this one to the next grid point. So I'll move this one to 1 because that's the next point. Then now I'm going to look for the height for 1. What's the height for 1? The height for 1 is 2. So I need to look for 2. And I can see that 2 is here. 2 is here. So I need to move on the 1. The height should be 2. So I move to make sure that I have this one here. But I'm just joining them because the height should be from here to here. This is 1. But I need to join it so that we can have it this way. Then I move to the next grid point. So I need to move to the next grid point, which is going to be this. Then I ask myself, what is the height for the 0? So the height for 0 is going to be, let me see, 3. Okay, so since the height for 0 is going to be 3, then we cannot just move to this point. So we need to go back and just increase the height. So let's increase the height to 0 because 0 is going to be 3. So we need to go here so that now we can add it here so that we can come to 0. Okay, so I think what we can do here is this. Let me do it this way so that you understand it well. So, but before you join the point, now look for the height and draw the height. So 2 is minus 1, good. 1 is 2. So we are moving from the right. 0 is 3, good. So I think that's the best way that we need to do. And then minus 1 is 2. So remember, we need to do up to minus 1. We are not going to add this one. So we are not interested in drawing the height for this. Then after you join them. So first, draw the heights for all the grid, the ones that you are looking for. Then now that we are moving from the right, we need to point them. So here one, now we move to the right. So let's go right. So now we can join this one together. And then this, before we can join this one on the right, we need to increase this one so that we can join this one together. And then this one too, before we move to the right, we need to also move it this way so that we can join this one together. So this is what it's going to be for the left. So the question says that sketch the graph along with the, okay, so the question did not ask us to sketch the left or the right. So it means that we need to finish it up. So let's finish it up by including the height for minus 2. So minus 2 is minus 1. So we are going to have minus 1 here. We are going to have minus 1 here. So we are going to have minus 1. Okay, so let's even use the right, because if not, it's going to be like we can draw from the left and the right. So let's use the right. Okay, let's just use the right, so that since the question is talking about right, we can just have the diagram to be like this for the right. All right, now let's move to question 4. Question 4, we want to find the definite integrals of the following functions, right? So this is equal to, so here we ask ourselves questions. What trig function, when I differentiate, I get secant squared? Yes, you are right. That's the tangent of x. Then we need to evaluate it at 0 and pi on 4. So what are we going to get here? This is going to be tangent of the upper limit minus tangent of the lower limit. So tangent is secant over quotient, right? So we know that secant of this is going to give us 1 minus, sine 0 is 0, so definitely this is also going to give us 0, and this is going to give us 1. That's basically what you're going to get. So here what I did was I was thinking of secant of pi on 2 divided by quotient of pi on 4. Sorry. Now on the unit circle, this is square root of 2 divided by square root of 2, and this is going to give us 1. So that's the reason why the tangent here is 1, if you don't know how to evaluate this. Now let's look at B. Now this is equal to, now exponential function is maintain the function and divide it by the derivative of what is on the top. So when I divide it, this is going to be 1, because when I differentiate x, I get 1. So 0 to natural log of 4, and this is e to the power x, 0 to natural log of 4. So now we can just do substitution. So plug in the upper limit, e to the power natural log of 4 minus e to the power 0. Now we have these guys together. So this is the same as 4 minus e to the power 0 is 1, and this is going to give us 3. Let's do C. C, we can use the power rule. So 3 here is constant, so we don't focus on it. I can factor the 3 out and have 1, 2, x squared dx. This is the same as 3. So now let's use the power rule on this. So this is going to be x squared plus 1 divided by plus 1 from 1 to 2. And this is going to be 3x cubed divided by 3 from 1 to 2. And we can cancel 3 and 3. So we are going to have x cubed from 1 to 2. Then plug in the upper limit, 2 to the power 3 minus 1 to the power 3. So 8 minus 1, and this is going to give us a big 7 from here. So that's question 4. And let's look at question 5. Now, it's always good to read the questions before you do. So evaluate the following limits, explain why they do not exist, show all your works, and use proper limit notation. Okay, so now let's look at how we can do this. So first, we have too much of assumption here. We can use the L'Hopital's rule, we can use any of them, right? But we need to check the assumptions before we do. So the first thing that we need to do anytime we are doing limit is do direct substitution. So let's do direct substitution and see what is going to happen here, right? So let me just write the limit here. So limit x is approaching 1 from the positive side, x plus 3 divided by x minus 1. This is equal to, so let's do direct substitution first. Now, because this is positive, we are interested in the denominator. That's where the problem is always. So when I'm just plugging in 1 on the top, I'm just going to plug in just 1. But the denominator, I'm going to use a positive. So this is going to be 1 plus 3. So you see that I'm not using the 1 positive on the top because, when you are on the top of the world, it's so happy, right? But when you are down, good, you are not happy. So let's use plus 1 here. So plus 1 here means that it's going to help us to indicate whether we are getting something 0, positive or negative. So this is going to be minus 1, and the top is going to be 4 divided by. So 1 positive means that we are picking value that is greater than 1. So any value that is greater than 1 is going to give us positive. For example, if I pick something like 1.1, 1.1 is greater than 1. So 1.1 minus 1 is going to give me something positive, which is 0.1. So it means that 1 positive minus 1 is going to give us something like 0 positive. When it's 0 positive, 0 positive can be 0.1, 0.2. And if I get a constant divided by 0, don't forget that if I have a constant divided by 0, this is going to be giving us infinity. But, the constant here depends, right? So since the constant here is positive, which is 4 already, then this is going to give us positive infinity, right? It means that it's going to give us positive infinity. So this is just the final answer, right? We don't need to do anything because we have a constant and we have 0 on the top. So this is going to give us positive infinity. Now let's work with this one too. So as I said, always direct substitution first. So let's do that. 6 minus 5 divided by 3 times 6 plus 1 is equal to 1 divided by 18 plus 1. And this is 1 divided by 19. So direct substitution first is always the key. Right. Good. Now here, x is approaching infinity. The question is open. The question did not ask us to use the L'Hopital's rule. So we can be using anything that we want to use, right? Here you can decide to use the L'Hopital's rule, or you can use something that you think you can move very fast. So here I want to move very fast instead of using the L'Hopital's rule. So here I'm going to use the idea of, x is approaching infinity. So it's kind of like horizontal asymptote something. So I'm going to compare the degree here because x is approaching infinity. So since x is approaching infinity, I'm going to drop all the terms with the lowest degree. So this is going to be equal to limit x is approaching infinity, and then it will be left with this divided by x squared. Because x is approaching infinity, x squared, which is the highest degree, is going to dominate all the rest of the functions. And this is the same as limit x is approaching infinity, and x squared can cancel and have 2, and this is going to give us 2. Another way to see this is also, you can say that, okay, let me compare the degree. The degree of the top is the same as the degree of the denominator, which is equal to 2. So the degree is the same as the top. They are all 2. So what we are going to do is we are going to compare the coefficient of the ones with the highest degree. So here it means that the limit is also the same as. So the coefficient of the top is 2 and the coefficient of the down is 1, and this is also 2. So any of them works. It's either you use this or you can also use this and then you are right. Good. And let's do the last one here and the limit here. Now this one is we have x to the power 3 over x. So here we have something that we need to do here. So here let's try and use the L'Hopital rule right here. So I'm going to say that this is equal to L, right? So what I'm going to do, if this is equal to L, so I'm going to have something like this. L is equal to limits x is approaching infinity, x to the power 3 divided by x. So I'm going to take the natural log on both sides. L is equal to limit x is approaching infinity, ln of x 3 divided by x. So the natural log will help us to drop the exponent here. So ln of L is equal to infinity 3x divided by x times this. Now what can we do again? This is the same as L, which is the same as limit x is approaching infinity, and this is the same as 3x divided by x. So first, let's verify if we can use the L'Hopital's rule here. So now plug in infinity, right, to see what is going to happen here. So natural log of infinity is infinity divided by, when I plug in infinity here, I'm going to get infinity. So it means that we can use the L'Hopital's rule. So now I'm going to have the natural log of L to be equal to, so now I'm using the L'Hopital's rule, so I'll put it on the top. Then I'm going to have limit this. So now let's differentiate length function. When I differentiate the length function, I'm just going to have 1 over x. So this is going to be 3 times 1 over x divided by 1. So what is going to happen here? Now this is going to be natural log of L, which is equal to limit x is approaching infinity. Now I can multiply this and have 3 over x divided by 1 is the same thing. So now we can now try to plug in infinity to see what is going to happen there. So ln of L is equal to, when I plug in infinity, this is kind of like I have 3 divided by infinity, and this is equal to 0, right? Because we have small number divided by big number. Then now we said our function is equal to L, so we need to find L here. And since we have the natural log function, then we need to come with the exponential function. So exponential function, and this is going to be L is equal to 1. So the final results here should be equal to 1. Right? We have so many ways of doing it, but this is nice to go through with respect to. Okay, let's look at question 6. We are almost done. We have like 10 questions which cut across all the exam 1, 2, and 3. So stay here. Let's learn together. Now here, let's just read the question, because always reading the question is the best way to do this. So Vo is standing on the top of SEO building, which is 100 meters height. So this will be our S, and throws a rock downward with a speed of 5 meters per second. So this is the velocity. This is our height, like, and then this is the velocity here. So the question is, assuming acceleration due to gravity is constant, find the velocity function in terms of time. So the first thing that we need to do here is, let's try and figure out all the information and let's put them down, right? Now, one thing that you need to know is acceleration due to gravity is equal to, okay, let me put it this way. Velocity is equal to okay, acceleration due to gravity is equal to v prime of t, and then velocity is also equal to s prime of t. Good. So that's basically what we are going to do here. But from this function, what we need to know from here is now v of t is equal to integration of a of t, and then s of t is also equal to integration of v of t dt. So this is what we are going to use with the blue one. So now let's figure out the information here. So Wo was standing on the top of the roof, right? So initial height is 10 meters. So here, if we are saying that the height is, let me assume it to be s, then our s of 0 is equal to 100. And then we have the initial speed, which is the velocity, which is also equal to 5 meters per second. And this is 5 meters, right? Now, we have the acceleration due to gravity to be this. So here, our a of t is equal to minus 10 per second squared. So this is what we have here. Now the question is asking us to find the velocity function, but we know that for us to find the velocity, we need to take the entire derivative of acceleration. So it means that the v of t is equal to integrate a of t. So this is going to give us integrate minus 10 dt, and minus 10 is a constant function. So this is going to give us minus 10t plus constant. So now that we have this, we need to find a constant, but we have the initial value here. So this is going to help us. So now let's plug in. When you compare this and this, you see that t is equal to 0. So now v of 0 will be equal to minus 10 times 0 plus t plus c. V of 0 is equal to 5. So we are going to have 0 is equal to 0 plus c, and c will be equal to, oops, this one should be 5. C will be equal to 5. So it means that our v of t is going to be 5. We put this one here. Nicely. Good. So let me write our v of t nicely. So from here, our v of t will be equal to minus 10t plus 5. So this is our velocity function. Now, the next one is find the height in terms of t. So the height is, okay, so since the question is saying the height, let's use, let me say h instead of s, right? So that we can see that this is the height, right? So the height is just taking the entire derivative of the velocity function. So this is going to be h of t, which is the height, is take the integral of v of t dt. So this is going to be minus 10t plus 5 dt. Let's do that. Now this is going to give us minus 10t squared divided by 2 plus 5t plus c. Right. Now we have the initial height, which will help us to find the constant. The initial height is 100. So we are going to have this one to be v of 0 is equal to minus 10 0 squared divided by 2 plus 5 of 0 plus c. V of 0 is 100, which is equal to 0 plus 0 plus c. So c will be equal to 100. So finally, our h of t will be equal to, okay, I can even simplify this. So I'm going to have this one to be minus 5t squared plus 5t plus 100. So this will be our height, which is the function, right, in terms of t. And then finally here, we want to find at what time does the rock hit the ground, right? So at what time? So here we are looking at the height. So for the rock to hit the ground, we need to just set this one to 0, and we just solve it. So that is when h of t is equal to 0. So here we are going to have minus 5t squared plus 5t plus 100, which is equal to 0. So first we can divide through by minus 5. So when I do that, I'm going to have 5t squared. 5 divided by minus 5 is going to be minus 1t, and this is going to be minus 20 is equal to 0. So we can find the factors here. So this is the same as t minus 4, t plus 5. Let's check if this is true. T times t is t squared. T times 5 is 5t. Minus 4 times this is minus 4t. So 5t minus 4t is just, oops. So it means that we need to swap this. This one should be positive and this one should be negative, right? So that we can have the middle to be negative, right? Because this is negative, so I need to make sure that it's negative. Is that right? Good. Okay, let me see what is happening here. Oh, okay. So I think we have some small. Okay, let me see something here. So I think this. I think I didn't see this. So downward. Let's look at this one here. We have downward here. So when we are going downward, I think our initial velocity should be negative. Yeah. So sorry about that. So this one should be minus. So is it going to affect our solution? Yes, of course. So it means that here our vein of this one is going to be minus. So C should be minus 5. Okay. So it means that we need to change this guy here and make it minus. What is my eraser? So I'm going to have minus here. So it's the same thing. So meaning that I need to change this one to be minus, change this one to be minus, and let's change this one to be minus. This one also, so this is still minus 0. It's fine. So C is still 100, but I think this is going to change to minus 5. Okay, so let's do that. This is minus. So when I divide through by minus 5, this should be positive. Okay, so if this is positive, then it means that we are going to have this one to be minus, this one should be positive. Okay, good. So now t times t is t squared, and this times this and this times this will give us positive t, and then when I multiply, I get that. So now my t here will be equal to 4, and my t here will be minus 5. So we are going to exclude this one here. So please, when we are doing it, pay attention to the keywords, okay? Because let's assume that I'm doing everything right, but I'm messing up with this velocity and I didn't see it. It means that I'm going to get everything wrong, right? Unless, let me say, the person who is marking is so generous enough to see that, oh, okay, the person is almost there. It's just the negative affected. So here we are going to choose our time to be equal to 4 seconds. 4 seconds. Okay, good. So that's what you are going to get for question 6. Let's move very quick to question 7. Now answer the following question by filling the squareness to the correct answer. Okay. So the first one is we have f of x to be the which of the following is the limit definition of the function. So what's the limit definition? Limit definition is f prime of x is equal to limit h is approaching 0, f of x plus h minus f of x all divided by h. So now let's look at this. What is f of x? F of x is given, right? So I can replace this one by f of x. So I can see that this one is here, is also here, is also here, is also here, right? But this is minus and this is positive. So automatically this is out because this is positive. Now this might be true, this one too might be true, this is also the same thing. Let's check s is approaching 0. Okay, so this is also out because h is approaching 0, but this is saying that s is approaching 0. So this is how you can take out some of the point out. So now the answer is depending on this and this. So now the only thing to check here is this one, f of x plus h. So let's see if it is this or this. So now let's try and look for f of x plus h. Now we have f of x, which is equal to square root of 3x plus 1. So as I said, I'm going to write this one as square root of, so I have my x here in the parentheses, so I'll put my x in the parentheses also here to have 3x plus 1. So that when I'm finding for x plus h, this is going to be square root of, so I'm changing everything in the parentheses to x plus h. So this is going to be 3x plus h plus 1. So you see that what is here is the same thing here. They are all in parentheses. And when I expand this, we are going to have 3x plus 3h plus 1. So we see that this one has no 3 to it. So it's this. So our answer here is going to be this one. Nice. So that will be that. Now let's look at this. If f is continuous and differentiable on this, and f of 1 is the same as this, then by the mean value theorem, f prime is equal to, so this one is easy to see that this is equal to 0. Why? Because we are saying that this is the same as this. Why? Because what is the mean value theorem? F prime of c should be the same as f of b minus f of a divided by b minus a. Now b is 5 and a is 1. So this is going to give us f of 5 minus f of 1 divided by 5 minus 1. But these are the same. So f of 5 and this is the same. So assuming that they are equal to 2. So if this is 2, this will be 2. 2 minus 2 is 0. And 0 divided by this is going to be 0. So this is kind of like, okay, they are the same. So I can write f of minus 1 is the same as f of 5. So I get 4. And this is going to be 0 divided by 4, and this is 0. So it's very simple. Anytime you see something like they are the same, and you are using mean value theorem, it's just going to give us 0 there. For which option is true for this here? Okay, now let's look at what is happening here. Now, for this to be the same, or for this to be true, then limit x is approaching 0 from the left of gen of x should be the same as, let me raise this one here, should be the same as limit x is approaching 0 from the positive of gen of x. So that's basically what we are going to look from here. So let's try and evaluate this. From the left, when I plug in 0, this will be 0, right? And this is equal to 3, so this is not going to work. Even though from the right, when I plug in 0, this is going to be 3. So this is going to be 0 when I plug in 0. So it's not going to work. So this is out. Let's look at this. This is having just one function. And when I plug in 0, either from the left or the right, we are not going to get 3, right? Because even if I do direct substitution with 0, plug in 0 here, 0 here, 0 here, this is going to be 14 divided by minus 7, which is equal to minus 2, which is not even equal to this when I plug in 0. So this is also out. So this is also out. Now let's look at this guy here. This guy is kind of squeezed here. So automatically this is the left, right? So the left is equal to 3. Now let's look at the right. Now the right is, now we are picking limits as x is approaching 0 from the positive, 4 minus cos of squared x. Now this is like kind of not divided by anything, so we can set x is equal to 0, plug it in. So 4 minus cos of 0 all squared. Cos of 0 is 1, all squared 4 minus 1, and this is going to be 3. So indeed the right side is also 3. So this is 3, this is 3, so it's true for this. So we are going to choose this one here. Good. So we don't need to even check the last one, right? Because definitely we need to make sure that. But let's read the last one. Gen of x has a vertical asymptote at x is equal to this. So definitely this is not true. Let's look at question 8. We are almost done. Now question 8 is saying that if two non-negative real numbers, x and y, have sum of 10. So non-negative means that a should be greater than 0 and b should be greater than 0. So pay attention. Sometimes the question will be like, if two positive. So if the question is saying that if two positive, then A should be greater than 0, B should be greater than 0. If the question also say that if two non-positive, then A should be less than 0, B should be less than 0. But this one, we don't use non-positive because basically we want it to be either greater than 0 or greater than or equal to 0. So pay attention to that. So the sum is 10. So A plus B should be equal to 10. And the question is, we want to minimize this. Right. So the first question here is find x and y such that this is minimized. Now to earn any credit, you must solve this problem. Okay, so we need to solve this. So this question is like, we need everything. We need to find the domain, even though the question is not asked, so that now when we are checking the minimum, we can know where we are working towards. So let's find the domain first. Now from here, we can make B the subject and have 10 minus A. So now, since we have B to be equal to 10 minus A, from this, we can substitute our B here, right? B is greater than 0. So this is going to be 10 minus A is also greater than or equal to A, because this is B is equal to this. So let's find for A. I add A to both sides. So I have A is greater than or equal to this. And this is the same as A less than or equal to 10. So our domain is going to be 0 and 10. Nice. Oops. Why am I using A? The question is X and Y. Sorry. Y. And this is X. This is X. And this is Y. X. X. This is supposed to be X. All right. Thank you. Now let's try and then find a function that we are going to optimize. So I'm going to plug in this inside this function. So since I'm going to have f of x to be x squared plus plug in y, and I'm going to have 10 minus x squared. This is the same as x squared plus, and let's try and expand this, or you can decide to use the chain rule. Any of them works out. So you can decide to expand or use the chain rule here. Any of them works. So we can decide to use the chain rule here. So this will be the function that we are going to optimize. So first we need to find a critical value. So we need f prime. F prime of x is equal to, now we can expand this or we can use the chain rule. So let's use the chain rule. And when I differentiate x squared, I have this plus, when I'm using the chain rule here, first I need to apply the power rule. So this is 2 down, 10 minus x. 2 minus 1 here will be just 1, so I don't need to write it. Times, differentiate what is inside, and it's going to give us minus 1. So this is going to be 2x minus 2, 10 minus x. And let's try this. Simplify. 2x minus 20 plus 2x. This is 4x minus 20. So for critical point, we need to make sure that this is equal to 0. So what value of x will make this one 0? When x is 5, we see that this is going to be 0. So let's try and solve it. Add 20 to both sides. Divide through by 4. And we have 5. So the critical point is 5. So we can decide to find y. So let's find y. Y is equal to 10 minus x. So y will be equal to 10 minus 5. And y is equal to this. So the question is just saying that find x and y such that we minimize it. So before we assume that x is 5 and y is 5, let's test them. We're using the domain so that we can know that, okay, x is equal to 5, x is 5 is the one that minimizes the function. So let's have our x. Domain is 0 and 10. and our critical point is 5. What is the function? F of x here, f of x is x squared minus, is a minus of plus 10 minus x squared. Plug in 0. When I plug in 0 here, this will be 0, 0 here will be 0. So 10 squared is going to give us 100. Plug in 5. When I plug in 5 here, this will be 25 squared, which is going to be 25 plus, when I plug in 5 here, this is going to be 5 squared again, 25, and this is going to be 50. Plug in 10. 10 here will be 0. Plug in 10 here, this is going to be 100, and indeed the minimum is here. So x and y, to minimize the function, should be when x is equal to 5 and y is equal to 5. So this is what we are going to get from here. Question 9, find the equation of the tangent line to the function. So this is cutting across everything, exam 1, 2, and 3. So equation of the tangent, first let's write the equation of the tangent there. So since the function is f of x, I'm going to use this one, y minus f of a is equal to f prime of a, x minus a. Now as soon as I write it this way, this is not my x, this is my a. So when I do that, I can do direct substitution here. I have y minus f of 1, f prime of 1, x minus 1. So I can find for f of 1 here. So what is f of 1? F of 1 is equal to 1 squared plus 5 times 1 minus 6. This is going to give us 1 plus 5 minus 6, and this is 0. So f of 1 is going to give us 0. Now we need just f prime of 1, but for us to find f prime of 1, we need f of x prime. So we need f prime of x, which is going to give us 2x plus 5. And this one will help us to find f prime of 1. So plug in 1, we have 2 times 1 plus 5, 2 plus 5, and this is equal to 7. So very simple. Let's do substitution. Let's go. Y minus f of 1 is 0. So look here. This is what we are using now. And then f prime of 1 is 7, x minus 1. And definitely this is going to give us y is equal to x minus 1. Easy, right? So we are done here. Now let's go to B. Now the B is saying that let L be the function tangent to A. Use A to approximate this. Okay. So we want to just approximate this. So it's just L of x, which is equal to y, with the 1 up there. So this is going to be L of x, which is equal to 7, x minus 1. So we want to approximate 0.9. So this is going to be L of 0.9, which is equal to 7, 0.9 minus 1. And this is going to be 7 times minus 0.1. And this is going to be minus 0.7. So very simple from there. We are almost done. Okay. Find the critical point or points of the function and then classify them, whether local maximum, minimum, or we don't have. Okay, so let's do that. So critical point, first we need f prime. Okay, so let's do that. F prime, so they've expand the function for us. So let's do that. This is 3x squared minus 3. That's nice. So this is the same as I can factor 3 out and have x squared minus 1. And then this one here is x minus 1, x plus 1. Now this is constant, so I'm not interested in it. I'm interested in what is going to make this one 0. So I can see that when x is equal to 1 and when x is equal to minus 1. So this will be the critical point. But let's put it on the normal line to see what is going to happen. So sign chart. I have minus 1 here, I have 1 here. Let's pick anything before minus 1. Let's use minus 2. In between them, let's pick 0. And after 1, let's pick 2. Plug in minus 2 inside f prime, and let's see what we are going to get. So minus 2, this is f prime, this is also f prime, this is also f prime. Any of them works. So when I plug in minus 2 here, or here, minus 2 here is going to be minus, and minus 2 here is going to be minus. Minus minus will be positive, so this is positive and increasing. Plug in 0, 0, 0, negative, positive, and this is going to be minus, so negative, decreasing. Plug in 2, 2 here, 2 here, everything will be positive, so this is positive and increasing. Oh, so this is nice. So what should be the minimum and maximum? So we have local max, s is equal to minus 1, and local minimum, s is equal to 1. Okay. Now let's look at B. Find the intervals on which the function is concave up or down. So for us to look at concave up and down, we need to look at the second derivative. So we need f prime prime of x. But we have f prime of x to be equal to 3x squared minus 3. So let's do that. Differentiate this one again and have 6x. So now the only value that will make this one f prime prime 0 is when x is equal to 0. So let's put it on the line and see what is happening. I pick this one on the line here, put 0 here. F prime prime, anything before here, it's not good for me to use a critical point, so I can pick something like 0.5 and then f prime prime of 0.5 here. 0.5 here is going to give us negative. Negative is concave down. 0.5 there is going to give us positive, concave up. So here we can see that we have concave up. Since we are looking for the interval, concave up is from 0 to positive infinity, and concave down is from negative infinity to 0. Now the question is saying that we should list any point of inflection. So since the point is changing here, then it means that point of inflection is at x is equal to 0. So that's what we are going to get for B. Now let's try and sketch this. So we have our critical points, right? Minus 1 and 1. Let's try and plug them inside the function. So critical point inside the function, f of minus 1, f of 1, and let's use the point of inflection too. Let's plug them in so that we can have exact value. Plug in minus 1 here. So minus 1 here is going to give us 1. Minus 1 here is going to give us minus 2. Is that right? Yes. Minus 2 squared is 4. 4 times this is going to give us 4. Plug in 1. 1 will make it 0. So at 1 we have 0. Okay. Plug in 0. 0 is 0 here, 0 here. So it's going to give us 2. So at 0, at negative 1, we have 4. At 1, we have 0. At 0, we have 2. Now remember, we have max at we have the max at 1. So max at 1 means that we are going to move down this way, and we have the minimum at 1, so it means that it's basically going to be this, that. So it means that we are even done drawing this graph, and concave up and down is happening at this line here, right? So now let's try and sketch the graph here. Very nice. So the graph is going to be, let me just move towards this. Let me just remove the point there. Good. So let me just try and sketch this side. Good. Good. So this is how the graph should be looking like. This is how the graph should be looking like. Yeah. So this is what you are going to have. What is happening at -2? We don't have -2 here. Yeah, we don't have -2 here. So yeah. So this is what we should be. This is what we should be having. So this is the graph. So we can see that minimum and a maximum, and then at this one at 0 is where we have the concave up and down. So you see that if I draw my line here, you see the concave up and then concave down happening at 0 here. So up and down. Good. So this is the graph for the function. Okay, so this is the end of the video, and in the next video we are going to tackle 2024 final exam. That one too is going to cut across everything from exam 1, exam 2, and exam 3, and something small that we did after exam 3. So make sure you stay here and then also come and learn with me when I start with the 2024. And make sure you subscribe, you like, and you share with friends to also prepare themselves and write their final exams with confidence. See you in the next one.